Let's do another example of doing it with this Pythagorean theorem method. So I've done it over on the left-hand side. You can see that's just setting up a regular triangle, solving for the hypotenuse using the Pythagorean theorem, and then going back to figure out what secant is. I don't want to do all that. I would rather just figure out, okay, well, can I use this Pythagorean relationship in order to figure out what secant theta is going to be? Absolutely. So we need to square 11/7 plus 1 is going to equal secant squared theta. So 11/7, that's 121 over 49 plus 1 equals secant squared. 121 plus 49s plus 49 49s, getting a common denominator, we get 170 49ths equals secant squared theta. We'd square root both sides, so we get the square root of 170. That doesn't simplify over 7 plus or minus equals secant theta. We need to decide if we want to use the positive case or the negative case. Well, in quadrant 1, secant is going to be related to cosine, and everybody's positive in quadrant 1. So we want the positive case. So just this square root of 170 over 7 will be our answer. Well, we're going to do this one final example. This is another one. It's like, oh man, this is so messy. There's so many things going on. Is there a way that we could simplify this, making it into something that's a little bit easier to work with? Yeah. Well, the way we can do that is we can multiply the numerator and denominator by the same thing. And that thing I want to multiply by is that thing I don't want to be dividing by in there. That's sine squared A. And we're just using a capital A on this one to be different. It means the same thing. So this equals, in the denominator, we've got 1 over sine squared A times a sine squared A. That's just turning into a 1. So nothing major happening there. In the numerator, we got to multiply this whole thing by sine squared A. So we get 3 sine squared A plus that thing divided by itself again. So that's just a 1. So this ends up just being 3 sine squared A plus 1. So that's another proof. We just proved that that big fractiony mess is the same as this thing right here. And I would rather do what's in purple there than that big fractiony mess on that other side. Now, our final sort of closing thought as we start working on these proofs, find a place that you want to put this. These are suggestions. The thing about proofs is I can't tell you a definite, like, yep, always do this. Yep, always take care of that. Yep, always do that. I can't give you like a step 1, a step 2, a step 3. That's the biggest problem with these proofs that people have. I can't give you steps. And the way you can only do them is just do things. That's the best advice I can give you, is just try something. If it works, great. If it doesn't work, try something else. See if something else is going to get you to your answer. There isn't a like, yep, this is what you should be looking for how you can solve these problems. So this is just meant to be like, I'm working on this proof, don't know what I should do, and I know I'm supposed to do stuff. What should I do? This is a collection of a whole bunch of things that you can try. There's one thing here that I really need to warn you about, is you should never write both sides of the thing that you're proving. So you can see here in this proof, I just have this side. I don't have the end goal of what I'm trying to get. When I first showed you this one, I didn't tell you what the end goal was. I knew I wanted to get to this, but I didn't tell you what that was. But as I work through my proof here in all these colors, notice that I'm not continually saying what my end goal is. I'm saying, this is where I'm starting. I'm going to work through some stuff. And if I can get to that, I've won and I've done my proof. So don't work on both sides. Pick one side and just work with that one. Do stuff like FOIL, distribute, combine like terms, do whatever you want as long as you follow proper algebraic rules of working with just one expression. Yeah. So that's about it for 7.2. We're going to continue to work problems together, but the biggest advice I can give you, just try something. If you have an idea of something you can do, try it. See what happens. See where it goes. If it goes somewhere good, great. If not, no big deal. Try something else. Uh, Thank you for watching. Have a good rest of your day.